Hello classmates, my name is Emily Heisero and my partner's name is Laura Beth McAllister, and we're going to present on the comparative toxicity of asbestos and carbon nanotubes for the environmental health class with Loeb Pockrell. So some of the objectives for our presentation today include defining asbestos and carbon nanotubes, or CNTs, determining the mechanism of toxicity and how these chemicals interact with humans in the environment, to explore the public health implications of toxicity, to highlight the history of regulations of these two substances, to highlight the existing regulations in effect right now, and lastly, to highlight regulatory gaps and propose recommendations for future regulations. So first, what is asbestos? Asbestos is 6 naturally occurring silicate minerals that contain long chains of oxygen and silicon. So below there are some close-ups of those 6 different types of asbestos. I'm not going to try to pronounce them, but there they are. So why and where is asbestos used? So first, asbestos is used because it is durable and heat/chemical resistant. It can be woven into many fabrics, and it can be used in many different types of insulating materials. So asbestos is most commonly found in homes or other buildings, as well as in our vehicles. So in the home, it's found in places like insulation, like in your roof or in between your walls, in floors, in boilers, heaters, and plumbing appliances, in a lot of electric equipment, as well as some appliances such as clothes dryers. And in our cars, it's found in places like the brake lining and the clutch facings. So what are carbon nanotubes, or CNTs? So carbon nanotubes are made up of an allotropic form of carbon. So if you remember back to high school chemistry, you'll recall that an allotrope is the ability for some elements to exist in different physical chemical structures, yet still retain the same properties of that element. So if you look at the picture, you'll see that a CNT is a seamless cylindrical structure with 2 forms. It can be either single or multi-layer. And importantly, CNTs are very, very small. Their diameter is always less than 100 nanometers. So why and where are CNTs used? So CNTs are used because they're strong, they're stiff, they have good electrical conductivity, and they also have really good thermal conductivity. So they can be used in places like radio antennas. They can also be used in biomedical engineering, such as in molecular syringes and molecular probes. And because of their electrical conductivity properties, they're also used to enhance solar and electric power. And they're also considered to be a nanofiller for composites. So if you look to the figure on the right, you'll see some different areas that CNTs are used. They can be used in aerospace, textiles, sports and leisure, automotive things, transportation, construction, medicine, energy, electronics. I think most notably they're used in lithium-ion batteries, like in our cell phones. So next, I'll talk about the mechanism by which these two substances are toxic. So they're toxic because there's the possibility that they can release respirable fibers into the air. So a respirable fiber is exactly what it sounds like. It's a fiber that humans can breathe in and get into the lungs, and that is not good. These fibers are most commonly released during production and processing, service life of the material or equipment that they're being used in, as well as disposal of that material. So, for example, with asbestos, if there was asbestos in the insulation of your home, it's most likely to be released when that insulation is being installed by workers. It can also be released in your home when you're just, being a consumer in your home and you have that insulation in there. And then lastly, it could also be released if that insulation were to be removed or the home is torn down or something. It's likely to be released during that time as well. So because of that, asbestos and CNTs are most commonly released around workers that are installing or building these materials, and then the consumers that are using them themselves. Other things that affect the release of these materials, specifically asbestos, is exposure to UV light and heat, chemical erosion and combustion. And for CNTs, the toxicity of released CNTs combined with fragmented matrix particles can be different than the toxicity of pristine CNTs, and therefore toxicity tests are very important. More about the mechanism of toxicity of asbestos and CNTs. So OSHA determines toxicity by the 3Ds, which are dose, dimension, and durability. Dimension refers to the size of the fibers. Only certain sized fibers are respirable. Like I said before, asbestos and CNTs are considered to be respirable fibers. And then durability refers to the ability of the fibers to persist in the body and is therefore sometimes called biopersistence. Some fibers can be broken down in the body more or less easily than other fibers. If a fiber is more durable, it is considered more toxic because it can then stay in the body for longer and has more of an opportunity and more time to cause harm in your body as your body attempts to break it down. And then lastly, dose is a combination of both dimension and durability and is often referred to as the lung burden. So OSHA recommends 0.1 respirable fibers per cubic centimeter per 8 hours as the permissible exposure limit for asbestos. So thank you. That was my half of the presentation, and now I will allow Laura to continue the rest of it.